waves, types of waves: mechanical waves, electromagnetic waves, and matter waves. Mechanical waves are of two types. First one is transverse and second one is longitudinal. In transverse wave, particles oscillate perpendicular to propagation of light, and in longitudinal wave, particles oscillate parallel to propagation of light. All electromagnetic waves are transverse wave. In electromagnetic waves, electric field and magnetic field, their variations are perpendicular to each other. Then matter waves we will study in atom, molecules, nuclei chapter. Then transverse mechanical waves are possible in solids and strings under tension, as well as on the liquid surface, but they are not possible in the fluid. Inside the fluid, not possible. Longitudinal waves are possible in solids as well as in fluids, and in air only longitudinal pressure waves can propagate. Then स्पीड कितना है लॉन्जिट्यूडनल वेव्स का? तो स्पीड ऑफ लॉन्जिट्यूडनल वेव इज रूट ऑफ बल्क मॉड्यूलस अपॉन डेंसिटी, रूट ऑफ बल्क मॉड्यूलस अपॉन डेंसिटी ऑफ दैट मटेरियल. दिस फॉर्मूला इज ट्रू फॉर किसके लिए ट्रू है? ओनली सॉलिड्स के लिए या फिर ओनली फ्लूइड्स के लिए? दिस इज ट्रू फॉर ऑल द मटेरियल्स, सब मटेरियल्स के लिए दिस फॉर्मूला इज ट्रू. And for solids, we can approximate this as root of Young's modulus upon density. This is approximation. This is accurate formula. Inside liquids and solids, velocity of sound is more. Velocity of sound is more. Compared to what? Compared to gases. Then उसके बाद क्या है? Velocity of sound in the air. कितना velocity air में? Root of bulk modulus upon density. But bulk modulus is different under different conditions. If we assume isothermal conditions, Newton assumed what? Sound travels in isothermal conditions. Therefore, bulk modulus becomes equal to pressure P. So P upon rho was the formula proposed by Newton. So if we calculate velocity by this formula, then there is slight error in the velocity. Then after that, Laplace proposed this change. He proposed that sound travels under adiabatic condition. So bulk modulus under adiabatic condition is what? Gamma into P. So velocity becomes root gamma P upon rho. Gamma for monoatomic is 5 by 3. For diatomic it is 7 by 5, and for triatomic it is 8 by 6. Gamma is Cp upon Cv. Then this is velocity gamma P upon rho. So P upon rho is replaced by RT upon M. M is molecular weight of gas, R is constant, gas constant, and T is temperature in Kelvin. So is there any effect of pressure on the velocity of sound? No effect. If we increase pressure, then density also increases. If we double pressure, then density also doubles. Therefore, velocity of sound does not change. Then is there any effect of temperature on the velocity? Yes. Velocity is proportional to root of T. if we take temperature in kelvins. If we take temperature in degree Celsius, this is the approximate formula. This is not accurate. Accurate nahi hai ye. This is approximate formula. Vt is equal to how much? V naught plus 0.61 into T. T temperature in degree Celsius. V naught is velocity at 0 degree Celsius. That is 332 meter per second. Then velocity is also dependent upon density. Velocity is inversely proportional to root of density. As humidity increases, density of the air decreases, and as density decreases, velocity of sound increases. What is the effect of wind velocity? We have to add wind velocity directly into the velocity of sound. If velocity of sound is 332 and if wind is flowing at the rate of 10 meters per second, then velocity of sound becomes 332 plus 10, 342. If wind velocity is at an angle of theta with velocity of sound, then we have to add v plus w cos theta, component of wind velocity.